Hi, everyone. Today I'm going to be talking about why carbohydrates are important for everyone's daily health. So, carbohydrates, by textbook definition, is an organic compound derived from plants and contains carbon, hydrogen, and oxygen. The simplest form a carbohydrate can come in is known as glucose, also known as a simple sugar. It is the main energy source the body uses. There are two classifications of carbohydrates, simple and complex. And carbohydrates, when broken down, are used to generate ATP, which is a type of energy used by skeletal muscles. So, carbohydrates can be classified into two groups, simple and complex. Simple carbohydrates are small compounds made up of one or two sugar molecules. Monosaccharides are made up of one sugar molecule known as glucose, fructose, and galactose, and disaccharides are made up of two sugar molecules known as sucrose, lactose, and maltose. Complex carbohydrates are made up of at least three monosaccharides. Oligosaccharides are shorter assemblies made up between 3 and 10 monosaccharides, and polysaccharides, known as starch, fiber, and glycogen, are larger assemblies made up of 10 or more monosaccharides. So, starch is a type of polysaccharide. It is glucose molecule change in alpha bonds, which means it is breakable and digestible by the human body. And after starch is broken down, glucose is absorbed into the bloodstream and they act just like any other glucose molecule. Fiber is another type of polysaccharide, and similar to starch, it is glucose molecule chains, but these chains are linked by beta bonds, which means they're unbreakable and undigestible by the human body. There are two types of fiber. There is soluble fiber, which means it is dissolvable in water and generally digested by gut bacteria, known as fermentation. And there's insoluble fiber, which is a structural component of cell walls, not dissolvable in water and not fermentable. Even though fiber can't be absorbed into the body, it does have some health benefits. It helps reduce the risk of developing colon and anal cancer, diverticulitis, and cardiovascular disease, and lowers total and LDL cholesterol. So, carbohydrate digestion starts in the mouth with chewing, which breaks down large polysaccharides, and salivary amylase, which is an enzyme secreted by the salivary glands, starts the chemical digestion of polysaccharides. Then they travel to the small intestine because they're not broken down small enough yet to be absorbed through the digestive tract. Um, Within the small intestine, there are villi, enterocytes, and microvilli that increases the area on the small intestine for absorption. And the pancreas secretes digestive enzymes to break down oligosaccharides and polysaccharides into smaller components that can be absorbed through the intestinal wall. So, carbohydrate absorption happens differently for some of the monosaccharides. So, glucose and galactose are absorbed by active transport process that requires ATP, and fructose is absorbed by passive diffusion that doesn't require ATP, so it stays in the small intestine for longer. So glucose has a few different metabolic fates depending on the cell's needs. So if the cells need energy, then glucose is used to generate ATP. But if the cells don't need energy, it is either stored in a reserve as glycogen for later use, normally found in the muscle and liver cell tissue, or converted to fatty acids and stored in adipose tissue. So glucose regulation, the normal levels that you want your blood glucose to be at during fasting is between 70 and 100 milligrams per DL. So within normal, it's known as euglycemia, below normal is hypoglycemia, and above normal is hyperglycemia. And it's normally maintained using the insulin dependent glucose transport. So, type 1 diabetes normally happens because of the insulin dependent. It happens when the insulin dependent glucose transport fails. And this The failure normally causes the glucose to build up outside of the cells, so it causes the blood glucose levels to raise. So, in the case of type 1 diabetes, the IDGT may fail due to the pancreas's inability to make insulin. So, there is no insulin to trigger the uptake of glucose. With type 2 diabetes, it is also caused by the failure of the IDGT, but in this case, the cells become insensitive to insulin, so insulin can't normally trigger the signal for the glucose transport proteins to move to the cell membrane and move glucose into the cell. So, carbohydrate can be used as a fuel source. So, glucose can be used to generate ATP through glycolysis in aerobic metabolism. And this glucose comes from either glycogen or blood glucose and gluconeogenesis. So the need for glucose as a fuel source is increased when the intensity of exercise is increased. So the recommendations for normal individuals differ from those recommended for active individuals. So the acceptable macronutrient distribution range is between 45 and 60% of your total energy intake. And the recommended dietary allowance is 130 grams, but this doesn't reflect the amount needed for daily activities or exercise. And it is recommended that the source of carbohydrate intake should be from high quality sources. The recommendations for active individuals, they range from 3 to 12 grams per kilogram per day. So the carbohydrate intake for these individuals go by body weight rather than in general. So as you can see here, the ranges differ based on the intensity of your training, as well as the athlete's body type and their training plan. So there are a few conditions related to carbohydrates, one of them being lactose intolerance, where the small intestine doesn't produce enough of the enzyme lactase to break down lactose, and celiac disease, which is an allergy to the protein gluten and hurts the inside of the small intestine wall. There are nutritive and non-nutritive sweeteners. Nutritive sweeteners have carbohydrates and give energy to the body. The most common types are sugars, such as monosaccharides and disaccharides, and corn-based sweeteners. The high levels of sugar intake can lead to some serious health problems or aid in the development of them, such as the raise in blood glucose levels, which can lead to diabetes. And non-nutritive sweeteners have carbohydrates similar to the other sweeteners, but they aren't digestive and give little to no energy to the body. And these are regulated by the FDA as food additives, and some are generally recognized as safe by the FDA, but others have to be approved before they can go out to the public for use. And all of the information that I got for this presentation is from our textbook in class.